Hello everyone, welcome to my class. In today's class, we are going to study about similar shapes and similar triangle. So let's see what are similar shapes. Two shapes are similar if one is enlargement of other. In similar shapes, angles in shapes are same and lengths of sides are related by a scale factor of enlargement. So mathematically you can say that two similar objects have exactly the same shape and proportion. But it may differ in size also. So I'll show you what does it mean actually. Okay, so I'll draw one, I'll draw two triangles. Now let me mark this one as 30, this one as 30 degrees. This one is 40 degree. This is also 40 degrees. And then I'll mark this one as 110 and 110 degrees. So you can see that here I have two triangles ABC and XYZ. Okay, now I will mark the length of the sides as well. Okay, now I will say that these two shapes are similar, and the reason is see, when you look at the angles of these two triangles, here I have 30-degree, and here also I have 30-degree. Then here I have 40 degrees, here also I have 40 degrees. Then here we have 110, and here also we have 110. So one thing is done that the angles are equal. Okay, in similar shapes, angles in shapes are same. So this is done. See, all the angles are same. Now we will see that lengths of the sides are related by a scale factor of enlargement, or you can also say that length of the sides are in proportion. So if you look here, this side AC is 5 and its corresponding side. So whenever we use the word corresponding side, it means the matching side which is similar to this side. So in this triangle XYZ, XZ is the corresponding or matching side with AC. So we always write the ratio of the corresponding sides or matching sides. So I will say here AC upon XZ, it has to be equal to AB upon XY, which should be equal to BC upon ZY. Now I write the ratios, whatever is the dimensions. So 5, AC is 5, XZ is 10, which is equal to AB, that is 3, and XY is 6, and BC is 2, and ZY is 4. Now you see that when I cancel it, I get 1 over 2, I get 1 over 2, I get 1 over 2. So this is clear that when we have two similar shapes, then their sides or the corresponding sides are in same proportion and the angle measure will be exactly the same. Now there is always a confusion arises with the word congruency and similarity. Okay, now there is a good difference between similar shapes and congruent shapes. See, whenever we speak about congruency, see, congruency is like being identical. So when we say the word identical, this is nothing but symmetrical, exactly the same thing. Two shapes are congruent if they are the same shape, exactly the same shape. They have same angles and length of sides. I'll give you a good example on this. See, suppose, let's see, we have two equilateral triangles. Okay, now, and one more I will write here. So let me mention this one as ABC. This one is LMN. This one we will take as PQR. Now you see, since I said equilateral triangle, so all the angles have to be 60 degree. So all the angles are 60 degrees, right? And then here also I will mark 60, 60, 60. Now you see that I will also write the measure of their side. So let me write this as 2 centimeter, 2 centimeter, 2 centimeter. Here also I am going to write same 2 centimeter, 2 centimeter and 2 centimeter. But here I will write this one as 6 centimeter, 6 centimeter and 6 centimeter. Now see, when we say the shapes are congruent, so it will go with this. Triangle ABC is congruent to triangle LMN. And the reason is, see, all the sides are exactly the same length. See, here AB is 2, LM is 2, AC is 2, LN is 2, and BC is 2. At the same time, MN is also 2 centimeter. So these two triangles which are identical, we call them congruent triangles. Now when we look at this triangle PQR, you can see that all the angles measure same. All the angles are 60 degree only, and this is also equilateral triangle. But I cannot say that these two triangles are congruent, and the reason is because the length of the sides or the measure of the sides are not the same, but they are in proportion. Okay, so always there is a difference between these words, similar and congruency. So remember this, don't mix it up. Now let's see, when we say that triangles are similar. Similar triangles have the same shape because their matching angles are equal. Okay, so it is nothing but the corresponding angles, and their sides are in proportion. So let's see, here we have two triangles ABC, PQR. When we look at the angle, see 105 here, here also 105. Here you have 40 degrees, here also 40 degrees, and 35 degrees here and here also. So we can see that these are the corresponding angles which are equal. Now that we have to show that these two are similar triangles. How? Now you see that when they are similar triangles, their lengths will be in some proportion, right? Okay, so I will show you few more examples. Now here, all of the following are true for similar triangles. So there are few points which you must remember that stands true for the similar triangles. So if you look at this triangle and then this triangle, see, you can see here this angle is equal to this angle. One line is there, yeah. And then here you can identify this angle is equal to this angle. So why they are marked like this? To show the difference between the angles, and that to show that these two angles are the corresponding angles, or you can say that matching angles. This and this one are another pair of corresponding angles. And then you can see that here we have three lines and here also three lines. It represents that these two are the corresponding angles and the angle measure is same, right? Now let's work on this one. So we have here two triangles. Okay, so we can see, we can check whether these two triangles are similar or not. So you can see here, here we have 63 degree, here we have 59 degrees. So obviously this we can find it out. So it will be 180 minus 63 plus 59. And then you get this is equal to 58 degrees. So this is 58 degrees. And now we will look for this angle as well. So here it will be 180 degrees minus 63 degree plus 58 degrees. and that will give you 59 degrees. So now we can see whether these two triangles are similar or not. So you can see very clearly that lengths are not same, lengths are not given, so we cannot compare right now. So we will just speak about the angles. Lengths are not same, they are not given, so this is smaller and this is the enlarged shape. Now you see that this angle is 63 degree and its matching angle here, again this is also 63 degree, and then here this is 59, and here also we got 59 degree, here we got 58 degrees, and here also we got 58 degrees. So we can say that these two triangles are similar because they have same angle measure. I hope this is clear to everyone. Now let's see another. Okay, this is very important point. On this you get many questions in IGCSE paper. Yeah, definitely you get one in both the papers. So here you can see two triangles A, B, C, D, E, F. Now, what is the first point? Internal ratios of the sides are same for both triangles. Okay, what are internal ratios? When you take the sides of same triangle, we call it as internal ratio. So here I am comparing the ratios of two sides of the same triangle with the ratios of two sides of another triangle. Now, so internal ratio when I am talking about, then I will take this side AB over BC of the same triangle. It should be equal to DE over EF. If we get the ratio same, then we can say that our two triangles are similar. Now, there is another way of proving that. That is comparing the ratio of corresponding sides. So whenever we say corresponding side, it refers to the matching side. So you can see AB is corresponding to DE. So you can see that both the sides look same. Then this is the larger one, and BC its corresponding is EF. AC its corresponding is DF. So ratios of corresponding sides are equal. So we can write the ratios AB upon DE is equal to BC upon EF, which is equal to AC upon DF. So I hope this is clear. We will see many more examples on this. Now you can see that here we have two triangles. Okay, now you can see that this is 90 degree, right? And the side opposite to the 90 degree is your hypotenuse, right? So you can see here the hypotenuse is 5 and hypotenuse is 10 here. So this length and this length are the matching or corresponding sides. So I will write the ratios 5 over 10. This is equal to 3 over 6. So this is the perpendicular length, right? And this is also perpendicular length. So I will write which is equal to 3 over 6. Now I will write the adjacent length or the base, that is 4 over 8. Now let's see. In this 1 over 2, 1 over 2, 1 over 2. So we can say that very clearly we can see that these triangles are similar triangles because their corresponding sides are in same proportion. Let's see few more. Now, there are few conditions which everyone must know. Now, two triangles are similar if they meet one of the following sets of conditions. Okay, so now there are four rules here. How can we say that two triangles are similar? See, all three pair of matching sides are in same ratio. So this we have done already. So you can see that this is the enlarged triangle and here we have the smaller triangle. Okay, so we can write the ratios like this. So I will take this one as the original one, and I will mark this one as the enlarged triangle, and I will write the ratio like this. So this side corresponds to this side. So I will write 9 over 3, which has to be equal to 6 over 2, which should be equal to 12 over 4. Now we will see whether they are in proportion or not. Now, so you can see they are in same proportion, that is 3 is to 1. So I hope this step is clear to everyone. This first point, all three pair of matching sides are in same ratio for the similar triangle. Now, here is another condition how you can say that two triangles are similar. Two pairs of matching sides are in same ratio and the included angles are equal. So what does it say? It says that two pairs of matching sides are in same ratio, or you can say corresponding side. So here you see, if you look at this triangle ABC and MNP, you can very clearly make it out this length MP is matching with the AC. Okay, and then another thing is two pairs of matching sides. So this is my one pair, and I'll take another pair as AB, and here you have another pair as MN. So two pairs of matching sides are in same ratio. So I will write the ratio 5 over 10, which should be equal to 3 over 6. Oh yes, they are in same ratio. Okay, and then included angles are equal. So the included angle is the angle between these two sides. So this one and this one. So since it is already marked, they are equal. So when you get two pairs of sides equal and the included angle between the side is equal, then our triangles are, what do you say, they are similar. So this one we can say, call this one as SAS similarity. Okay, this is SAS similarity. Okay, so I didn't tell you about this one. What similarity is this? All three pairs of matching sides are in same ratio. Then we call it as SSS similarity because all three sides are equal. The second one is SAS. Yeah. Now, two angles of one triangle equal to equal two angles in the other triangle. So here we are talking about AA similarity. AA similarity, which represents that two angles of the triangles are same as the another triangle. So here we can see very clearly, here it is mentioned L and Q. So we can say angle NLM is equal to angle SQR. And then you can see here it is presented angle LMN is equal to angle QRS. So when you can prove the two angles of two triangles are equal, we can say that the triangles are similar by AA similarity rule, right? Then, this is the last one. The hypotenuses of two right angle triangles and another pair of matching sides are in same ratio. So when we speak about right triangles, how can we say that they are similar? So what it says, hypotenuses of two right angle triangles. So where is the hypotenuse? So this is your hypotenuse opposite to 90 degree, that side is your hypotenuse, and here also opposite to 90 degree is hypotenuse. So let me write this. So I will write this as ratio 4 over 10. Now this should be equal to, it says another pair of matching sides, so equal to 1.5 over 3.75. Let's solve this. Now when I work on this, I'll get 1 over 2.5. 2.5. So what we can do, we just write it like this: 150 over 375 divided by 25, and you get 6 over 15, which is nothing but 1 over 2.5. So you can see here 1 over 2.5, and here also 1 over 2.5. So we can say that these two triangles are similar. Now, wow, this is very important to understand. What is scale factor? Now, based on this scale factor, you get many questions in exam, like the questions based on area and volume. Now, understand this properly. What is scale factor? Now you see that when two shapes are similar, the ratio of their corresponding sides gives the scale factor. But how do we write it? Actually, you have to know that the scale factor is nothing but side length of the final triangle upon the side length of the original triangle. So you look here. Here we have one triangle ABC. So this is my original triangle. So I can mention this one as the original one. Now, this triangle is the enlarged form of this original one. So this is my enlarged triangle. Now, understand this. When we have to find the scale factor, you will write side length of the final triangle, that is the enlarged triangle, upon side length of the original triangle, upon this triangle. Okay, so following this rule, what is the scale factor here? Scale factor is equal to, see, the length of enlarged shape is 6. 6 upon the original one is 3. So 6 over 3, that gives us 2. So we can say that scale factor of this triangle, the enlargement of this triangle to this, of I mean ABC to EFG is 2. Okay, now let's see another one. So this is very, very important question. This is very important topic, whatever you say. Now, the ratio of the areas of similar triangle, or you can call it as area factor, is equal to the square of the scale factor. So understand this. Ratios of areas of similar triangle. So suppose we have area 1 upon area 2. Okay, this will be equal to the square of scale factor. Scale factor we represent by k. So it will be square of the k. Now, actually, what is this k? Here only we did scale factor. This k is nothing but the scale factor, that is side length of the final triangle upon the side length of original. Okay, now let me change this to area of final and this area of the original triangle, because I'm going to write my scale factor is written in this that way. Now let me write this one as the final triangle and this one as the original. Right. Now you see that we studied earlier scale factor, that is k, which is equal to the length of the final triangle. So length of the, you can say final, generally we are getting enlarged one, upon the length of original. Now when I put it here, it will be area of the triangle, final triangle, upon area of the original triangle. This ratio is equal to k squared. What is k? It is length of enlarged upon the, or let me mention this as final. Here I have written as final. So length of final triangle and length of the original. So length of the final over length of the original and this whole thing is squared. Yeah, you definitely get this question in paper 2, as well as sometimes you are using this as structured question is paper 4. Now, so I can also, okay, let me solve this one. Here, your triangle is 20 centimeter. It has got one side measure as 20 centimeter, excuse, and the another one side is 30. The area of the smaller one or original one is given as 187.5, and here the area, oh, we need to figure it out. So we can write it like this. So we know the formula. So I will write area of final upon area of original is equal to what? It is the k square. So I'm going to write it in form of length. So it will be length of the final one upon the length of original triangle, and the whole thing is squared. So finally, using this rule, we can write like this. Here area is given for the original. So area of the final we are finding. So area of the final one upon 187.5 equals final length is 30 squared upon original length is 20 squared. Now let's do it further. So we got, now we will cross multiply and you will get 20 squared area of the final, which is equal to 30 squared times 187.5. So final area you will get, okay, let me expand it now. 30 squared will become 900 into 187.5 over 400. Okay, now put everything in your calculator and you get here 421.875. So you can definitely write this as approximately equal to 421.88 centimeter squares. Don't forget to mention the unit. This is very important, right? So see, your formula is area of the final triangle upon area of the original triangle, which is equal to the ratio of the lengths and whole squared. So that's why we have area of the final upon, this is the area of original, the first one, that is 187.5, which is equal to, so 30 squared upon 20 squared. Now we will simplify it by cross multiplication and you get the value. So very easy it is. Okay. Now, okay, this is another shape. Same thing, nothing changes here. Everything is same. Now, as I said, area of the final upon area of the original. So area of the final shape upon area of the original. It is always equal to L length of the final upon length of the original. Don't mess up with this. If you have written the final or enlarged shape as as numerator, then the length will also be in at the numerator place. So never mess up. So for this we can write, so you can see here very clearly area is given over here and we have to find the area of this one. So I will write like this. Let me mention this only as the final, and here area will be 17. And now this is equal to 15 squared over 7 squared. And now what we can do is we can just do cross multiplication. So you get 49a equals 15 squared times 17. So this is 225 times 17, right? And the next step will be area equals 225 times 17 over 49. And then again put everything in the calculator, and then here you will get 3825 over 49, which is equal to 78.06. Because this is 6 here, so we can also mention this as, we can round it, 78.1 meter square. Easy? Yeah, this one is very easy. Now let's see one more shape. Good. So the same thing here, length is given, area is given. Here length is given, area is not given. So we have to find the area of this. Let me mark this as A and this as B. So I will say area of A over area of B, which is equal to, definitely don't forget, 80 squared upon 50 squared. So we can solve it. Okay, let me replace the value. Area of A is already given, that is 4000. When we cross multiply, area of the B shape and 80 squared is equal to 4000 times 50 into 50. Let me write this. And then area, this area of shape B equals 4000 times 2500 over 18 to 80. And we solve it and we will get 1562.5 meter squared. So we did, okay, so we did 3 questions on area and similar shape. Now we have another part. Now look here. Volume of enlarged cuboid is multiple of original volume by scale factor k cube. Okay. Now, so I have mentioned here about the cuboid. You can also say of any shape. Okay, volume of any enlarged shape is multiple of original volume by scale factor k cube. What does it mean now? So it says that volume factor is nothing but the ratios of volume. Ratios of volume equals scale factor whole cubed. Again, same thing. What is the scale factor? It is nothing but the ratios of the length. So we can call it V1 upon V2 equals L1 upon L2 whole cubed. So this is the formula for finding the volume or length for similar shapes. So let's do this one here. Volume is given for this larger one. Let me say this is V1 and let me mark this one as V2. So following this rule, we will write it V1 over V2 equals, let me write the rule first, L1 cubed upon L2 cubed. So V1 we don't know, so let it be V1 only, and V2 we know, that is 288, which is equal to L1. So this one will be 5 cubed upon this one will be 12 cubed. Right? So writing these values properly is much more important than solving it. So once your values are in place, you can do anything then. So we do just cross multiply, and what is this? This is cubed. So I should write it smaller. So 12 cubed V equals 5 cubed times 288, and V equals, so I must write this as 125 times 288 over 12 times 12 times 12. Yeah. And then we can solve it. Yes. So when you put in your calculator, solve this completely, and you will get 36,000 over 1728. So your volume will be 20.83. It's 33, and the 3 keeps on going actually. So we can just round it to approximately equal to 20.83. Don't forget to mention the units. It is centimeter cubed. Now, okay, so now we will see how to calculate volume for this shape. So here you can see that here volume is given, volume for this one is not given. Okay. And here this vertical length is given, and here also vertical length is given. So we know it is already, let me mark this one as A and let this one as B. So we can write it easily. Volume of A over volume of B equals length of A whole cubed upon length of B whole cubed. So volume of A we know that is 9. Volume of B we don't know that. We need to calculate, which is equal to length of A is 3 cubed over 4 cubed. Now we do cross multiplication and then you get 27. So 3 cubed is 27. So 27 volume of the B1, and that equals to 9 times uh, 64. So volume of the B1 is 9 times 64 over 27. So we can solve it now. 9 3s is 27 and 3 2s is 6, 3 1s is 3, and then we keep on getting 3. So this will be volume of the shape B is 21.3 millimeter cube. So far it looks good, easy. Now, yeah, another similar shape we have. So look at these two cylinders. So volume is given for this one as well as this one also. So here volume is 10, here volume is 640. Here we know the radius 9, and here we don't know the radius that we need to calculate. So it's simple. We know that. Let me mark this one as 1 and 2. So I will say ratio of the volume is equal to ratio of the length and whole cubed. Sorry, yeah, cubed. Why did I write this? Yeah, this is cube. So we know that V1 is volume 1 is 10 and volume 2 is 640, and the length one, that is the radius, that is 9 cubed over L2, this, that is nothing but R, and I need to figure it out. Okay, let's see how to do this. Now we can do cross multiplication. So you get 10r cubed, which is equal to 9 cubed times 640. And then, okay, we can solve it further. R cubed is equal to 9 cubed times 640 over 10, and this cancels. So R cubed equals, sorry, R equals, we will remove this. This is cube root of 9 cube into 64. So we know that 64 is nothing but 4 cubed. So it will be cube root of 9 cubed times 4 cubed. And when we bring out the common for cube root, it will be 9 times 4. 9 times 4. Hence, your radius is nothing but 36 centimeter. Yes. So we did on question on area, we did question on volume. Let's see a few more questions based on this. Yeah, this question looks good. So here you see in the triangle below, calculate the lengths of sides P, Q, and R. Okay, so here is your P, here is Q, and here is R. So if you look at this, it looks easier to calculate the value of P first. So how we can write that? Okay, so P is the corresponding side of this 3 centimeter, this base. Now you can do one thing, you can consider these two triangles as two different triangles. So this is one triangle, and then this is the smaller one, and this will make your work much easier. And this whole length is 12 centimeter, and this whole length we don't know, we are not aware. And then here the base is 3 centimeter, and here base is P, this we need to calculate. Okay, and then here this length is just this much. So this is your 5 centimeter, and we know that this length will be 3 plus 5. The whole length is 8 centimeter. Okay, so now we know the corresponding sides, and huh, this is question mark. Okay, so we can write our ratios. This and these are two corresponding sides. So I will write 3 over P, which is equal to 5 over 8. 5 over 8. So this is easy. 5P is equal to 24, and P equals 24 by 5. That equals to 5 fours 20.4.8. I hope this is easy to understand. Okay, now, so I will not go in order. See, here we need to calculate Q also. But what I think, if I calculate R, it is easier to calculate Q. So, to calculate this length R, okay, so I should mark this as R, not a question mark. Okay, so we know the corresponding lengths. So we can say R over 12 equals 5 over 8. 5 over 8. So 8R equals 12 times 5, and R equals 12 times 5 over 8. And now 4 to 6, 4 3 is 12, and that will give you R equals 15 over 2, nothing but 7.5. Okay, now this makes my work easier to calculate Q. What is Q? Q is the part of this whole length which is measuring 12. And here R we have calculated, that is 7.5. So I can say that Q plus R equals 12. Q plus R we have already 7.5, that equals 12, and Q equals 12 minus 7.5, and then 12 minus 7.5 will give you, it will be 4.5, and we are done. That's it. Just don't forget to mention the units. Yeah, this was another easy, just because of these two, like this is compounded triangle, a smaller triangle in the larger one, that makes it look little different, not much. Let's see a few more questions. Wow. Now the triangles PQR and LMN are similar. Okay, so these two are similar. Now what to do? Calculate the area of triangle PQR. Okay, that's easy. Area of triangle PQR, because we have the height, we have the base. So, A part, area of triangle PQR. That will be, you know this already. Area of triangle is half base into height. So we will write half 4 times 5, that will give you 10 centimeter squared. This part is done. Now second part, the scale factor of enlargement. So see, the scale factor, if you remember, um, length of length of final triangle upon the length of original one. Okay, So we know this already. This is the enlarged final one and this is the original smaller one. So we will write this. So this will become 8 over 5 and that will be 1.6. So your scale factor is 1.6. Now let's see third part. This says the area of triangle element. Okay. So we have calculated area of PQR here. Now we need to calculate area of element. So what is missing here? Now we don't have the height given over here. But the good thing is we know two lengths. These two lengths we know, and we also know the scale factor. And we know the relation between the length of the similar shapes and the scale factor. So following that, we can write it like this. Area of, okay, LMN upon area of this triangle PQR. Okay, I'll write it. Triangle area of PQR equals 8 squared upon 5 squared. Now let's write other values. So we are looking for area of LMN. So let me write it this way. Area of PQR is 10, which is equal to 64 over 25. And now we can solve it here. So we will write this 25 area of LMN equals 64 times 10, and then area of LMN equals 64 times 10 over 25. And then we can solve it further. So area will be area of LMN equals 128 over 5, which is nothing but 25.6 centimeter squared. So this is also done. So in for the smaller triangle, we didn't do any scale factor thing because we have the height here. So we went with the formula of area of triangle, that is half base into height, and we got the area. And then in the next part of the question, scale factor of enlargement. So we know the rule, the length of the final triangle or final shape upon the length of original triangle or shape. That will we will write. So this is the final and this is the original. So 8 over 4, scale factor is 1.6. Now to calculate the area of triangle LMN, since we can see that height is not given here, but we have the one length, and here also we have one length, and we have the scale factor. So using the relation between the scale factor and the length, that is ratio of the areas is equal to square of the ratio of the squares of the length, and hence we can solve it. So this is done. Okay. Also we have few more questions over here. Now here you can see that triangle ADE shown below has an area of 12 centimeter square. Okay, so this small triangle, so I can draw it here small, ADE. ADE, this has got the area of 12 centimeter square, and here we have one length, that is 6 centimeter, the given height. And okay, let me write it another way. So your triangle A D E, and this is the length 6 centimeter. This has got area of 12 centimeter square. Now your question is calculate the area of triangle ABC. What is triangle ABC? This is the larger one, so we can write it like this: triangle A, B, C. And what length is given? We know the vertical length, that is the height. So I can write this as directly 6 plus 4, that is 10. And we need to figure out what is the area of this triangle. So we already know that area of triangle, or you can say that ratios of the triangle. So I will write it like this. Mm, area of triangle ADE over area of triangle ABC is equal to ratios of the lengths, square of the ratios of the length. So it will be 6 squared upon 10 squared. So we can just cross multiply. Okay, so area of ADE we have, that is 12. 12 upon area of ABC equals 36 over 100, and 36 times area of ABC equals 12 times 100, and then area of ABC equals 12 times 100 over 36. So further we solve it and we get 33, 33.3, and 3 keeps on repeating. So this is the area. Easy one. Yeah. Now let's see. I guess we are left with one or two more questions. So let's see this one. In the given triangle ABC, if AC is parallel to EF, find the length of AC. So it is already mentioned here, EF is parallel to AC, and then we have to find the length AC. Now when we look at this carefully again, here you have two triangles. So I can say that the smaller triangle is BEF, where BF is 5.1 centimeter and EF is 3.6 centimeter. And then we have another larger triangle, that is BAC. So we can write this length BC as 5.1 plus 7.3. So 5.1 plus 7.3. Okay, and what else is given? We need to calculate AC. This has to be calculated. Okay, we can write the ratios now. So we can write it. Let's write the corresponding sides first. BF over, we can go with the internal ratios as well. BF over EF, which is equal to BC over AC. Now we substitute the values over here. BF is nothing but 5.1 over EF is 3.6, which is equal to 5.1 plus 7.3 will give you 12.4. So we have 12.4 over length AC. Now what we can do is we can cross multiply, and on cross multiplication you will get 5.1 AC equals 12.4 times 3.6. Then AC equals 12.4 times 3.6 over 5.1. So you can substitute everything in your, just put everything in the calculator, and you can get the answer as 8.75 centimeter. Hopefully this is question, paper 4 question, so that you can use calculator. Yeah. Let's see how many more questions. I guess this should be the last. Yeah, one more. Yeah, this is the last question. In the given triangle ADC, find the length of BC. Okay, so we again here also we have two triangles. See, one is this one, um, AEB, AEB, and another one is ADC. So we can write it like this. See, corresponding sides are, we have to find BC. Okay, so we can write this as AB over AC. See, AB over AC equals BE over DC. So AB is 1.73. Okay, and AC. No, I will change it. I will write it in different way because But it's all the same, I do it anyway, but still I will change. Okay, I will write it this way: AB upon BE, which is equal to AC upon DC. Now AB is 1.73, B is 0.82, AC is AC is 1.73 plus BC over 2.23. Okay, so you have to be good at calculation and you have to solve it very carefully. Now we will do cross multiplication, and then you get 0.82 times 1.73 plus BC. Don't forget to put the bracket, otherwise it will be a blunder. So 1.73 times 2.23, and now 1.73 plus BC equals 1.73 times 2.23 over 0.82. So you will get here 1.73 plus BC equals, this one we multiply and we get 3.8579 over 0.82. And now we further solve it, so you will get BC equals, and you can solve this in your calculator, so you get 4.70, and this 1.73 will transpose and it will become minus 1.73, and then BC equals 2.97, and this is done. So we are done with so many questions, and whatever we have done, most of these questions are your past paper exam style questions. You need to practice all of this. Okay, so this is actually important topic for international maths 0607, then 0580 and 0606. So please practice on this. If there is any doubt, mention in the comment box. Thank you for being here with me till end.